Everyone, in this short video, I want to share some of my observations on animation systems of existing digital content creation software. I will try to categorize them into the following 6 categories, and I think this will provide a general framework and guideline in planning our animation production. The 6 categories we have here is traditional 2D, transform and keyframe based, deformation based, and something what I call static interactive systems or limited dynamic systems. The 5th category is called proceduralism, and the last one is whole scene simulation. As we will see, in general, the idea way for anyone who is not into animation before will think everything could be simulated on the whole scene level, but in reality that is not really possible. The first thing we want to look at is the traditional 2D. This is actually in my opinion, the best way to understand how everything works, and it's most flexible in general. So traditional 2D, to put it simply, just to draw everything every frame. So here we draw a circle on the first screen, and then on the next frame we draw a box. So that is what becomes the animation. That is the traditional 2D, and the grease pencil is a very good example of it. Now there's a lot of stuff you can do with this. For instance, you can separate the layers and keep the static scene not animated as much and animate only the dynamic scenes, right? So that's why I say this is the most flexible one. The next one I want to take a look at is the transform and keyframe based. Now, this one is very interesting because if we use Blender as an example, and you can always animate those location, rotation, and scale. This is what I mean by the transform and keyframe based animation, right? So that way I have quickly animated those things. The limitation with this one, especially in Blender, is most of the time you can only animate those properties that are either a number or very single toggles, like this kind of things. Actually you cannot even animate the visibility property, which cause a lot of problem when you are doing motion graphics, because you need to have a way to hide those objects that you do not need it at any given moment. But that I think is more like a limitation of Blender itself, because if you go outside of Blender, for instance, if you use Houdini, and here you can see we have a font, right? So in Blender, every text is like a text level data, so you cannot animate it. But in this case, text is just a property, and you can indeed animate this one. So if we do keyframe, set keyframe, and then go to the next frame, we do something else, and then we can set the keyframe again. Then as you can see, if we don't hide it, as you can see, the value will just be animated, right? So that is, as I said, more like a limitation in Blender, which can only animate numerical properties. So, but in general, that is what I mean by the keyframe based animation. You can also animate other stuff. For instance, you can animate shader values. In this case, if we go to shading, and if we change the stuff like diffusion and reflection of things, you see you can animate the roughness, right? So that is a way to allow you to animate more than just the transformation. But in general, that is what we mean by keyframe-based animation. Now, deformation is an interesting one that is usually used together with what we call skeletal animation or armature animation. So one example here is this guy, which is a character, and he can do a bunch of stuff. This is controlled by using a skeleton. That is one way of this kind of deformation-based animation. Another way you can do deformation-based animation is by using shape keys, which is also called morph target, as in Unreal Engine. You can see here we are just animating on the geometry data level, right? So both of those are what I call a deformation-based animation. Now the fourth system we are going to look at is something what people would consider as dynamic simulation, but I prefer to call it static and static interactive systems or limited dynamics. And the reason I call it will become evident if we look at the environment here. So here I have an environment. So in this environment, what do we have here? We have a smoke emitter. So when you start the animation, you can see there is what people would call a dynamic system, right? But the reason I call it static interactive or limited dynamic is this box contains the entire smoke simulation, and the outside environment actually has no idea of the existence of this smoke, right? You can of course add condition body at condition shapes, but in general, the smoke simulation has no idea of the external environment. And what you are actually doing is to compose this small piece of bounding box inside this larger environment, right? So that's why I would prefer to call it static interactive system. And we can see if we contrast it with the next kind, that is the proceduralism, where you can actually combine things, give them relationship, and that is making it a little bit more dynamic in a sense. Before we go that, there is another thing we want to look at. It's called a particle, which I also consider under the fourth category. So here we have a very simple particle here, and here I have a wind. So if you play with this, you can see there is spheres falling down, but you can of course tune up the wind strength and give it a direction, so you can see the scene moves in another direction, right? So again, this is a limited interactive system because it doesn't affect other things, right? So here I have a object, and the object is apparently not affected by the wind. So as you can see in this case, this thing lives in its own world, and those two lives in another world. We're just composing them together, putting them inside a single thing, right? And that is the fourth category. Now the fifth category is very interesting, called proceduralism. Proceduralism is, in a nutshell, giving constraints or using expressions to express the relationship between things. That way we provide a more interesting dynamics. So one example here, if we look at Blender, let me close this one. If we look at Blender here, we have this very simple thing. So we have a box, but notice what happens when I move the box. The camera will actually follow it, right? This is achieved using a very simple track 2 constraint. But this one is what I call proceduralism, and this one allows you to have dynamic effects that's neither keyframed nor static or not aware of what's going on in the outer world, right? So that's one example of proceduralism. Another example of proceduralism is to use expressions. So in this case, we have this font value here. This is a different one. So here you can see the frame number will automatically update, right? That is achieved by using an expression, and that expression is giving this text value a relation to the actual time frame. So that is another way you can do that. You can of course do even more interesting stuff, like visualizing the sound, the sound wave of a music by doing this kind of relations by using a channel operator in Houdini, right? So that is the fifth type. Now, the sixth type, the whole scene simulation, is something, for instance, if you just go into a physical world and everything there is constantly interacting with each other, and you would expect to just put a camera there and capture everything, and then that is your final animation, right? This is unfortunately not really possible except in video games. For instance, here in Minecraft, we can put water, and then you can see the whole thing just simulating itself, and the world is of course interacting constantly. If I just remove this sand block, the one above it will fall down, right? And you can imagine if you can put a camera here, you can capture the whole thing. That is what I mean by whole thing simulation. This is unfortunately right now not really possible in existing DCCs unless you do extensive scripting. So that is my take on the animation series, and I wish this kind of categorization system help you understand how you might structure your scene and plan your shots, and you eventually make your animation in a more informed way. Thank you for watching.